The 15-ton armored vehicle had plunged into the ravine with Private Johnson trapped inside as floodwaters rose rapidly around the wreckage. Standard recovery equipment was 6 hours away. Johnson had maybe 30 minutes of air left. Mechanic Davis looked at the impossible physics: one man, basic tools, and 15 tons of steel that needed to be lifted before water filled the cabin completely. The MRAP had rolled during a convoy ambush, coming to rest upside down in a flash flood channel. Water was pouring through damaged seals, and Johnson's panicked voice crackled through the radio, "Water's at my waist, Davis. I can't get the hatch open." Sometimes engineering school doesn't prepare you for the moment when physics meets desperation. At Forward Operating Base Warrior in Iraq's volatile Al-Anbar province, vehicle recovery operations required specialized expertise in heavy equipment mechanics, tactical recovery procedures, and emergency response techniques that could restore mobility to disabled military vehicles under combat conditions where equipment failure could prove fatal for personnel depending on armored protection. Staff Sergeant Michael Davis served as the senior vehicle recovery specialist with expertise developed through 8 years of military mechanical training, civilian heavy equipment experience, and specialized certifications in tactical vehicle recovery that qualified him for operations where standard recovery procedures required adaptation to combat conditions and equipment limitations. Davis possessed comprehensive knowledge of military vehicle systems including MATV mine-resistant ambush-protected vehicles, maintenance procedures for complex mechanical systems, and recovery techniques that could restore operational capability to damaged vehicles using available equipment and improvised methods when specialized recovery assets weren't immediately available. His civilian background included heavy equipment operation, industrial mechanics, and construction equipment repair that provided understanding of hydraulic systems, mechanical advantage principles, and improvised lifting techniques that exceeded standard military recovery training and enabled innovative approaches to challenging recovery scenarios. Military vehicle recovery training had included specialized courses in tactical recovery procedures, heavy equipment operation, and emergency response that prepared recovery specialists for operations where vehicle recovery determined mission success and personnel survival in environments where mobility represented the difference between tactical success and catastrophic failure. Davis's expertise extended beyond basic recovery to include battlefield damage assessment, emergency repair procedures, and equipment improvisation that enabled vehicle recovery using available resources when specialized equipment wasn't accessible due to tactical conditions or equipment limitations that required creative problem-solving approaches. The vehicle fleet at FOB Warrior included over 200 armored vehicles requiring constant maintenance and recovery support due to combat damage, environmental conditions, and operational stress that challenged mechanical systems beyond normal specifications while requiring maximum reliability for personnel protection and mission accomplishment. Recovery operations in Al-Anbar province presented unique challenges including enemy activity that could interfere with recovery operations, environmental conditions that complicated equipment access, and tactical constraints that limited recovery time and required rapid restoration of vehicle mobility for continued operations. Tuesday afternoon brought routine convoy operations as Davis supervised maintenance activities while remaining on standby for emergency recovery operations that could be required throughout the region where vehicle breakdowns and combat damage created constant demand for specialized recovery expertise and immediate response capability. At 1,430 hours, Convoy Bravo 6 reported enemy contact during routine supply operations approximately 15 kilometers northeast of FOB Warrior. The convoy consisted of 6 mine-resistant ambush-protected vehicles transporting critical supplies to forward operating positions where material shortages could compromise defensive capability and operational effectiveness. Initial reports indicated that enemy forces had initiated coordinated attacks using improvised explosive devices and small arms fire designed to disable vehicles and eliminate convoy personnel through tactical ambush operations that demonstrated sophisticated understanding of American convoy procedures and vehicle vulnerabilities. The lead MRAP, call sign Warrior 7, operated by Private First Class Robert Johnson, reported mechanical damage from IED explosion and was attempting evasive maneuvers when communication indicated loss of vehicle control during high-speed tactical movement through terrain that challenged vehicle stability and driver capability. Emergency communications revealed that Warrior 7 had experienced catastrophic rollover during evasive maneuvers, coming to rest in a flash flood drainage channel where seasonal water flow created additional hazards for vehicle recovery and personnel evacuation under conditions that exceeded normal recovery scenarios. Davis immediately recognized the tactical and technical challenges presented by vehicle recovery in hostile territory complicated by environmental hazards that could prove as dangerous as enemy activity for recovery operations requiring extended time and specialized equipment that might not be immediately available. Initial assessment indicated that Warrior 7 had rolled completely over, coming to rest upside down in a position that prevented normal egress procedures while potentially trapping vehicle occupants in a configuration that standard escape procedures couldn't address effectively under emergency conditions. Weather reports indicated that flash flooding was possible due to upstream precipitation that could rapidly transform the drainage channel from manageable water levels to life-threatening flood conditions that would make vehicle recovery impossible while creating additional survival challenges for trapped personnel. Enemy activity in the area continued as hostile forces maintained pressure on the remaining convoy vehicles while potentially preparing to target recovery operations that would require American forces to remain in vulnerable positions during extended recovery procedures that could provide opportunities for enemy attack. Communication with Johnson inside Warrior 7 revealed that he was conscious but trapped inside the overturned vehicle with water beginning to enter the passenger compartment through damaged seals and blast holes that had compromised vehicle integrity during the IED explosion and subsequent rollover. Davis conducted rapid assessment of recovery requirements using his mechanical expertise and knowledge of MRAP vehicle specifications that revealed the full scope of challenges facing any recovery attempt in the flash flood channel where environmental conditions complicated every aspect of standard recovery procedures. The overturned MRAP weighed approximately 15 tons fully loaded with armor, equipment, and supplies that had shifted during rollover to create unpredictable weight distribution that would complicate lifting operations using any available recovery equipment or improvised lifting systems that could be constructed using field-available resources. Vehicle position analysis indicated that Warrior 7 was resting on its roof in a drainage channel approximately 8 feet deep with the vehicle's wheels pointing skyward and passenger compartment partially submerged in water that was increasing due to upstream flow and seasonal precipitation that could rapidly worsen flood conditions. Standard recovery procedures required specialized equipment including heavy recovery vehicles with lifting capacity exceeding 20 tons, stabilization equipment for preventing additional vehicle movement during recovery operations, and safety equipment for protecting personnel during complex recovery procedures that normally required multiple trained specialists. Equipment assessment revealed that available recovery assets included basic towing equipment rated for much lighter loads, manual lifting devices with limited capacity, and improvised tools that could potentially be adapted for emergency recovery but lacked the specifications required for safely lifting 15-ton vehicles under optimal conditions. Time analysis indicated that water levels were rising at approximately 6 inches per hour based on current precipitation and upstream flow conditions, creating a timeline where vehicle recovery needed to be completed within 30 minutes to prevent complete submersion of the passenger compartment where Johnson was trapped. Communication with Johnson revealed that water had reached chest level and continued rising while vehicle orientation prevented him from reaching emergency egress points that had been designed for upright vehicle operations rather than completely inverted emergency situations that trapped occupants below normal exit routes. Davis understood that conventional recovery doctrine required waiting for appropriate equipment and personnel that could provide adequate safety margins and technical capability for complex recovery operations. However, Johnson couldn't survive the time required for conventional recovery asset deployment from main base locations. Standard recovery procedures emphasized that recovery operations shouldn't endanger additional personnel through attempts that exceeded equipment capability or safety parameters established to prevent recovery teams from becoming additional casualties requiring rescue during complex operations that challenged technical and safety limits. Davis developed an innovative recovery approach using mechanical advantage principles, available equipment, and improvised engineering that could potentially Provide lifting capability sufficient for vehicle recovery despite equipment limitations and environmental constraints that exceeded normal recovery parameters. The solution utilized hydraulic jacks rated for heavy vehicle lifting, combined with lever systems that could multiply applied force through mechanical advantage techniques that exceeded individual human strength limitations while remaining within equipment capacity ratings for available tools and improvised lifting systems. Primary lifting points required identification of vehicle structural elements that could support lifting loads without causing additional damage that might compromise passenger compartment integrity or create structural failure during lifting operations that would stress vehicle components beyond design specifications. Stabilization systems were necessary to prevent vehicle shifting during lifting operations that could cause additional rollover, crush injuries to personnel working near the vehicle, or mechanical failure of improvised lifting systems that weren't designed for dynamic loading conditions created by unstable vehicle positioning. Mechanical advantage systems required construction using available equipment including tow chains, winch systems, and improvised fulcrum points that could multiply applied force while maintaining operational safety for personnel operating improvised equipment under emergency conditions that exceeded normal safety parameters. Environmental considerations included water management to prevent rising flood levels from overwhelming recovery operations, debris removal that could interfere with lifting equipment positioning, and timing coordination that balanced recovery speed against operational safety for personnel working in hazardous conditions. Communication systems needed establishment for coordinating lifting operations between Davis and any available assistance personnel while maintaining contact with Johnson inside the vehicle to monitor his condition and provide psychological support during the recovery attempt that represented his only survival option. Emergency procedures required development for equipment failure scenarios, rapid evacuation if flooding overwhelmed recovery operations, and medical response for Johnson's condition after successful vehicle recovery that might reveal injury sustained during the initial rollover and subsequent entrapment. Davis positioned hydraulic jacks at structurally sound lifting points on the overturned MRAP while establishing lever systems that could multiply lifting force through mechanical advantage. Principles that enabled one person to generate lifting capability normally requiring multiple personnel and specialized equipment under optimal conditions. Initial lifting attempts revealed the enormous forces required to overcome vehicle weight, water resistance, and mechanical friction that challenged improvised lifting systems beyond their normal operational parameters while requiring precise coordination to prevent equipment failure during critical lifting phases. Communication with Johnson indicated that water levels inside the vehicle had reached his shoulders while his condition showed signs of hypothermia and panic that could compromise his ability to assist with escape procedures once lifting operations created sufficient clearance for emergency egress. Hydraulic jack positioning required careful attention to weight distribution and structural integrity as lifting forces concentrated stress on vehicle components that hadn't been designed to support vehicle weight in inverted configuration while partially submerged in water that added hydraulic resistance to lifting operations. Mechanical advantage systems enabled Davis to generate lifting forces that gradually raised the vehicle's roof section above water level, creating airspace that allowed Johnson to breathe normally while continued lifting operations worked toward creating sufficient clearance for emergency escape through damaged vehicle openings. Environmental conditions continued deteriorating as water levels rose and weather conditions brought additional precipitation that threatened to overwhelm recovery operations if lifting procedures required extended time periods that exceeded the available window before flood conditions made continued operations impossible. Equipment performance monitoring revealed stress indicators in improvised lifting systems as hydraulic jacks approached maximum capacity while lever systems showed signs of mechanical strain that indicated operation near failure limits that could result in catastrophic equipment failure and vehicle resubmersion. Davis implemented systematic lifting procedures that gradually raised vehicle sections while monitoring equipment performance and Johnson's condition throughout recovery operations that balanced lifting speed against equipment safety and flood timeline constraints that determined success or failure of rescue operations. Progress indicators showed gradual vehicle elevation as water cleared critical areas of the passenger compartment while creating access opportunities for Johnson's emergency escape once sufficient clearance could be achieved through continued lifting operations using equipment operating at maximum capacity. After 20 minutes of continuous lifting operations, Davis achieved sufficient vehicle elevation to create emergency escape routes for Johnson while maintaining lifting force that prevented vehicle resubmersion in rising floodwater that continued threatening to overwhelm recovery operations before completion. Johnson's escape required careful coordination as his weakened condition from hypothermia and panic limited his physical capability for rapid movement through narrow escape routes that had been created by lifting operations. Davis provided continuous encouragement and escape instructions while maintaining lifting systems. Emergency egress succeeded as Johnson escaped the overturned vehicle through a blast-damaged section that had been elevated above water level by improvised lifting operations. His condition required immediate medical attention for hypothermia, possible injuries, and psychological trauma from the near-drowning experience. Vehicle recovery completion required controlled lowering of the MRAP using the same improvised systems that had enabled lifting operations. Davis carefully released lifting force while ensuring that lowering operations didn't create additional hazards for personnel or equipment in the immediate area. Environmental conditions validation confirmed that flood levels would have completely submerged the passenger compartment within minutes of Johnson's successful escape, demonstrating that the improvised recovery operation had been completed within critical time constraints that determined survival versus fatal outcome. The psychological challenge of the recovery operation extended beyond technical and physical demands as Davis faced the enormous pressure of knowing that Johnson's life depended entirely on his ability to overcome engineering limitations and equipment constraints that had never been tested under such extreme conditions in actual field operations. Mental stress accumulated as each minute of operation brought Johnson closer to potential drowning while equipment operated at maximum capacity with increasing risk of catastrophic failure that could instantly reverse all progress and doom the rescue mission to failure. Davis had to maintain focus and technical precision while managing psychological pressure that could impair judgment. The weight of responsibility for another soldier's life created mental pressure that exceeded normal operational stress as every decision could determine survival versus death for Johnson, who had no alternative escape options if improvised recovery techniques failed to provide adequate lifting capability within critical time constraints. Communication with Johnson throughout the operation provided both motivation and additional stress as Davis could hear the fear and desperation in his voice while water levels continued rising inside the vehicle. Maintaining Johnson's morale while managing his own stress required exceptional mental discipline and leadership capability. Technical problem-solving under extreme pressure required Davis to constantly analyze equipment performance, adjust procedures based on changing conditions, and make critical decisions about risk versus safety while operating improvised systems that had no established safety protocols or performance guarantees under emergency conditions. The isolation of solo operations meant that Davis couldn't rely on team support or additional expertise for critical decisions that could determine mission success or failure. Every technical judgment and equipment modification had to be made independently while accepting full responsibility for outcomes. Fear management became essential as Davis recognized that equipment failure could result in his own injury or death if lifting systems collapsed catastrophically while he was positioned near heavy equipment operating at maximum capacity. Personal survival instincts had to be managed while maintaining focus on rescue operations. Time pressure created additional mental stress as Davis calculated remaining time before flood conditions would make rescue impossible while monitoring equipment that showed increasing signs of stress that could lead to failure before mission completion. The race against time required maintaining hope while preparing for potential failure. During the most critical phase of lifting operations, equipment performance indicators revealed stress levels that approached catastrophic failure as hydraulic jacks operated beyond rated capacity while mechanical advantage systems showed metal fatigue and connection stress that threatened immediate collapse of entire lifting systems. Hydraulic jack performance monitoring revealed internal pressure readings that exceeded manufacturer specifications while external visual inspection showed seal deterioration and structural stress that indicated imminent failure if loading continued at current levels. Davis had to balance continued lifting against equipment preservation for mission completion. Mechanical advantage systems displayed warning signs including metal fatigue cracks and improvised lever arms, connection point stress that created dangerous load concentrations, and fulcrum instability that could cause sudden system collapse with catastrophic results for rescue operations and personnel safety. The critical decision point required Davis to choose between continuing operations with equipment that might fail catastrophically or reducing lifting force to preserve equipment functionality while accepting that reduced capability might not achieve sufficient elevation for Johnson's escape before flood conditions overwhelmed the operation. Equipment failure analysis required real-time assessment of crack propagation in metal components, stress distribution across improvised connections, and hydraulic system degradation that could cause sudden pressure loss and immediate collapse of lifting capability when Johnson's survival depended on continued elevation. Risk calculation involved balancing probability of equipment failure against time remaining for rescue completion while considering that equipment collapse could injure Davis and eliminate any possibility of rescue for Johnson, who would be trapped without any alternative escape options. Innovation under pressure required Davis to implement emergency reinforcement techniques using additional available materials to strengthen failing components while maintaining lifting operations that couldn't be interrupted without losing critical progress toward rescue completion. Emergency backup procedures included positioning additional equipment to provide redundant lifting capability if primary systems failed, creating alternative escape routes that didn't depend on maximum vehicle elevation, and preparing for rapid personnel evacuation if equipment failure created immediate danger. The psychological impact of operating equipment at failure limits while responsible for another soldier's life created stress levels that challenged Davis's ability to maintain technical precision and safety awareness during the most critical phase of rescue operations when any mistake could prove fatal. Convoy operations resumed after Johnson's recovery and medical treatment, with Warrior 7 recovered for repair operations that would restore the vehicle to operational status. The successful recovery prevented loss of critical equipment while saving Johnson's life through innovative recovery techniques that exceeded conventional capabilities. Enemy forces in the area had been deterred by the rapid recovery operations and continued convoy activities that demonstrated American capability to overcome tactical challenges and maintain operational momentum despite equipment casualties and environmental hazards that could have compromised mission effectiveness. Intelligence assessment indicated that successful vehicle recovery had prevented enemy forces from capturing sensitive equipment and materials while demonstrating recovery capability that could influence enemy tactical planning regarding attacks on American vehicle convoys throughout the operational area. Training value of the recovery operation provided valuable lessons for other recovery specialists regarding improvised techniques and equipment adaptation that could enable successful recovery operations when conventional procedures weren't adequate for emergency situations requiring immediate response capability. Unit morale benefits included demonstration that technical expertise and individual initiative could overcome circumstances that appeared insurmountable according to conventional assessment, providing confidence that unit members would receive maximum recovery effort regardless of tactical or technical challenges involved in rescue operations. Davis received the Army Commendation Medal recognizing his technical achievement and innovative recovery operations that had saved Johnson's life through individual expertise and determination that exceeded conventional recovery procedures and demonstrated exceptional technical capability under emergency conditions that challenged both equipment limitations and human endurance. The medal ceremony included recognition from senior military leadership who emphasized that Davis's actions represented the finest traditions of military technical expertise and personal courage applied under circumstances that required innovation beyond standard procedures and acceptance of personal risk for fellow soldiers' welfare. More importantly for Davis personally, Johnson's survival represented successful application of mechanical knowledge and innovative problem-solving that had prevented tragedy when conventional procedures couldn't provide adequate response within critical time constraints that determined life or death outcomes for soldiers depending on technical expertise for survival. The psychological impact of successful recovery operations extended beyond immediate tactical success to demonstrate that individual technical expertise, combined with determination and creative problem-solving, could overcome circumstances that appeared impossible according to conventional engineering assessment and equipment specifications that normally governed recovery operations. Davis's improvised recovery techniques became standard training material for vehicle recovery specialists throughout the Army, demonstrating individual innovation and technical capability that could overcome circumstances that appeared impossible according to conventional recovery assessment and equipment limitations that typically determined operational possibilities. The recovery operation became a detailed case study for military engineering schools and recovery training programs, providing practical examples of mechanical advantage principles applied under field conditions, equipment improvisation using available resources, and emergency response techniques that could save lives when standard approaches proved inadequate for complex scenarios. Technical analysis of Davis's recovery methods provided scientific validation for mechanical engineering principles including leverage calculations, hydraulic system applications, and force multiplication techniques that had previously been considered theoretical knowledge rather than practical emergency procedures that could be implemented under field conditions. Training programs incorporated Davis's innovations into curriculum for vehicle recovery specialists, providing hands-on instruction in improvised lifting techniques that included hydraulic jack positioning for maximum effectiveness, mechanical advantage systems construction using field-available materials, and emergency response procedures that could be implemented when specialized equipment wasn't immediately available. The specific techniques taught included proper fulcrum positioning for leverage systems, load distribution calculations for multiple lifting points, hydraulic system operation under emergency conditions, and safety procedures for preventing equipment failure during critical recovery phases when personnel's safety depended on continued system operation. Research and development efforts analyzed the recovery operation to identify equipment improvements that could enhance standard recovery capability while maintaining safety standards appropriate for emergency operations. These studies led to development of improved portable lifting equipment and emergency response protocols. International interest in Davis's techniques led to knowledge sharing with Allied military forces and civilian emergency response organizations that dealt with vehicle recovery challenges in remote locations where conventional equipment and procedures weren't accessible for emergency response operations requiring immediate technical solutions. Davis's expertise became invaluable for developing advanced training programs that exceeded standard capabilities when circumstances demanded extraordinary efforts that could save lives through individual technical innovation and determination that refused to accept conventional limitations when soldiers depended on recovery operations for survival during emergency situations. The successful recovery demonstrated fundamental principles that individual technical expertise, when combined with innovative thinking and determination, could achieve results that violated conventional engineering assessment while proving that necessity could drive innovation beyond normal human and equipment limitations under emergency conditions requiring immediate response. Davis continued serving in vehicle recovery operations while developing specialized training curricula that prepared other recovery specialists for emergency situations requiring improvised techniques and innovative approaches that exceeded standard procedures and equipment capabilities during complex recovery scenarios. His reputation as an innovative recovery specialist led to consulting opportunities with equipment manufacturers who sought to understand field requirements for emergency recovery equipment that could provide enhanced capability while remaining portable enough for rapid deployment during tactical operations. The psychological impact on unit personnel demonstrated that technical expertise combined with individual determination could overcome seemingly impossible circumstances, inspiring confidence that recovery operations would be attempted regardless of conventional limitations when soldiers needed assistance during emergency situations. Johnson's complete recovery and return to duty validated the success of innovative recovery techniques while providing proof that individual technical expertise could achieve results that exceeded conventional capabilities when applied with determination and creative problem-solving under emergency conditions. The recovery techniques developed by Davis influenced military vehicle recovery doctrine by demonstrating that emergency procedures could exceed standard expectations when individual expertise was combined with innovative problem-solving and willingness to accept calculated risks that exceeded normal safety margins but proved acceptable under life-threatening conditions that required immediate response. Military engineering analysis of Davis's recovery methods provided comprehensive scientific validation for mechanical advantage techniques and equipment improvisation that had previously been considered theoretically possible but practically difficult to implement under field conditions without specialized equipment and optimal operating environments that weren't available during emergency situations. The technical documentation process included detailed analysis of hydraulic system performance under extreme loading conditions, mechanical advantage calculations that had enabled successful lifting operations, and equipment stress analysis that identified performance characteristics under emergency conditions that exceeded normal operational specifications by significant margins. Engineering research teams conducted extensive testing of Davis's techniques using controlled laboratory conditions to validate field results and develop improved procedures that could be taught to other recovery specialists. The research confirmed that mechanical advantage principles could enable lifting operations that exceeded equipment ratings when properly applied. Advanced training programs incorporated Davis's innovations into curriculum for vehicle recovery specialists, providing hands-on instruction in improvised lifting techniques that included hydraulic jack positioning for maximum effectiveness, mechanical advantage systems construction using field-available materials, and emergency response procedures that could be implemented when specialized equipment wasn't immediately available. The training curriculum development included creation of realistic training scenarios that simulated emergency conditions where conventional recovery procedures wouldn't be adequate, enabling recovery specialists to practice improvised techniques under controlled conditions that prepared them for actual emergency situations requiring innovative approaches. International military cooperation programs facilitated knowledge sharing with allied forces who faced similar vehicle recovery challenges in remote locations where conventional equipment and procedures weren't accessible for emergency response operations. Davis's techniques were adopted by multiple allied military organizations for emergency response training. Research and development efforts analyzed the recovery operation to identify equipment improvements that could enhance standard recovery capability while maintaining safety standards appropriate for emergency operations. These studies led to development of improved portable lifting equipment that incorporated lessons learned from Davis's improvised systems. Equipment manufacturers consulted with Davis regarding design improvements for military recovery equipment that could provide enhanced capability while remaining portable enough for rapid deployment during tactical operations. His field experience provided valuable input for engineering teams developing next-generation recovery systems. Civilian emergency response organizations also studied Davis's techniques for application in disaster response situations where heavy equipment recovery might be required using limited resources. Fire departments, search and rescue teams, and disaster response agencies incorporated modified versions of his techniques into emergency response protocols. The psychological impact on military personnel demonstrated that individual expertise combined with determination could overcome seemingly impossible circumstances, inspiring confidence that recovery operations would be attempted regardless of conventional limitations when soldiers needed assistance during emergency situations that exceeded standard response capabilities. Academic institutions including engineering schools and military colleges incorporated Davis's recovery operation into case study curricula that demonstrated practical application of mechanical engineering principles under emergency conditions. The case study provided real-world examples of physics principles applied for life-saving purposes. And that's Mechanic Davis's vehicle lifter story, the soldier who defied physics to save a drowning brother. Here at Last Signal Stories, we honor every mechanic and recovery specialist who refuses to accept that impossible means abandoning someone in need. If this story of technical innovation, mechanical genius, and never giving up moved you, hit subscribe for more military stories. Drop a comment below, would you have attempted that impossible lift like Davis? Until next time, stay tuned for the signal.